All right, well, I hope everybody's doing all right today. We've got a great showing of attendees for this webinar. They're still filing in a little bit, but with the interest of time, we'll get started with the first couple slides here, and hopefully they finish piling in the next couple minutes. But this is great. A lot of people. Anyhow, welcome to the American Foundry Society's Foundry Sand Beneficial Use webinar. This will be the first in a series of two. Today we will focus on the EPA risk assessment of spent foundry sands and how states are using the risk assessment to advance beneficial use. We're hoping that foundries and trade associations in every state can take advantage of this, this awesome document that was put together. Here's the agenda for today. First, we'll touch on a few logistic type items, introduce our presenters, touch on why beneficial use is so important, concise overview of the EPA risk assessment. We'll go over 3 case studies on how some states have, are, and may be able to use the risk assessment. Sneak peek at next week's webinar. We'll wrap things up with a conclusion and answer a few questions that you have at the end. All attendees enter the webinar automatically muted to avoid distracting nuisance background noises and such. The webinar is scheduled for 1 hour. We'll do our best to keep to the 1 hour. You can ask a question at any time by typing it in under the questions tab in your control panel for the webinar. And we'll answer some of those questions at the end. All questions and answers will be saved and available in a post-webinar report. And the presenters' email addresses will be provided to you if you'd like to follow up with any of us and answer any more specific questions that maybe we don't touch on. So we'll give you our email addresses at the end. Brief introduction to your presenters in webinar number 1. Dan Ullman, Principal Consultant with Haley & Aldrich, out of Ann Arbor, Michigan. He has over 3 decades of environmental management experience in the foundry industry and has been an active AFS contributor for just as long. He is one of the elite EHS minds who are responsible for getting the US EPA involved with USDA to conduct the foundry sand risk assessment in the first place. He thinks Mike Lenahan is awesome. Mike Lenahan, Vice President of Sales with Fairmont Sand Trawl out of Benton Harbor, Michigan. His nickname is Stash, not because of the cool mustache, but because he has made a career of helping people like us find places to stash our spent foundry materials. He's a true beneficial use guru. He was also part of the group responsible for gaining US EPA's involvement with the risk assessment. Brian Esch, Environmental Coordinator for Waupaca Foundry out of Waupaca, Wisconsin. Excuse me. Brian has over 20 years of experience in the foundry industry and has had oversight of beneficial use projects in 4 different states. He likes cheese and unfortunately the Packers too. I'm Greg Kramer, Corporate Environmental Engineer with ME Global out of Duluth, Minnesota. I dabble at doing real work from time to time and think presenting a webinar might actually help people take me seriously. I will read anything Mike puts on the teleprompter. Yeah. All right, this is the question I am sure you've all been asking. Why beneficial use? Reduce, reuse, recycle, right? It's imperative that we conserve our natural resources, recycle our foundry sand within our processes until it can no longer be used to produce good castings, and then put it to use again in more permanent soil-related applications. Reusing perfectly good foundry sand is the right thing to do, and everyone benefits from it. Extending the capacity of landfills, promoting sustainability, and it can also save money by reducing disposal costs and reducing material costs for the end user of the material. Reasons are obvious, simple, and even a bit cliche, and the list of reasons goes on. But even with this simple rationale, it isn't and hasn't been all that easy to get beneficial use projects approved in many places across the U.S. Now there's another reason. A very powerful tool to promote the beneficial use of Foundry sand is the 2014 release of EPA's risk assessment of Foundry sand for soil-related applications. Beneficial use of all kinds of materials has been gaining traction over the recent years, with some states implementing and reforming beneficial use regulation and legislation. In fact, the EPA states, based on the results of the risk assessment, the EPA and the USDA support the beneficial use of these materials that would otherwise go to waste. This indicates an opportunity for us as an industry. The risk assessment and EPA's stance on beneficial use can be the key to affecting change in your state. Now I will hand control over to Dan Oman so he can tell you everything you need to know about the risk assessment. This document is the reason the EPA and many state agencies now believe that beneficial use of Foundry sand is protective of human health and the environment.
Thanks, Greg. I hope you all can hear me. As Greg mentioned, he's done a very good job. Okay, thank you. Greg's done a very good job of telling you some of the reasons why you should be interested in beneficial reuse. What I'm going to do is walk you through the US EPA Foundry sand risk assessment. I'm going to try to tell you two important things. One, tell you what it is, but almost just as importantly, I want to stress what it's not. It's important that we as an industry understand the limitations in this risk assessment so that we can properly apply it as a good tool for beneficial reuse. In terms of the outline, I'm going to go over the research that was conducted by US EPA that served as the foundation for the risk assessment. Then I'll go over the risk assessment process very briefly for some of you that may not be that familiar with risk assessment techniques. Then I'll cover some of the risk assessment results that came out of this study. And then ultimately identify some potential benefits to you in terms of your application of the risk assessment to your beneficial use projects. Okay, in terms of the research that served as the foundation for the risk assessment, basically the cost of the research is somewhere in the neighborhood of $5 million. It resulted from an earmark that was put in the federal budget for the U.S. Department of Agriculture, Agricultural Research Service. It came out of some significant lobbying efforts on the part of Ohio Cast Metals Association and AFS. It took about 5 years to complete this research, and the major question that the research was designed to answer was, is recycled foundry sand suitable for use in soil-related applications? And those soil-related applications are, as you see on the screen here, basically manufactured soils, soil-less potting media, and road subbase. And again, this was a joint research effort on the part of USDA and the Ohio State University. Okay, there were 43 samples of foundry sand that formed the basis for this research. They came from 43 foundries, and here's the first limitation I'm going to tell you. All of these samples were samples of molding sand or spent molding sand. In other words, it was sand that had been through the production process, as opposed to those sands which had not been through the production process, such as broken cores or floor sweeping. So it's very important to keep that in mind. There were 3 rounds of sampling that were conducted from the 43 foundries. And of those 43 foundries, you see that they were predominantly iron foundries, 31 of them. 6 were steel foundries, 4 were aluminum, and 2 were copper-based. And of those 2 copper-based foundries, they poured a low-lead alloy. And this is important to keep in mind going forward as well. In terms of the sands that were used, the vast majority of the sands were silica-based sands. 2 of the foundries used olivine sands. Again, this is a very small sample, and you'll see how that limited the results or the scope of this risk assessment going forward. Binder systems were predominantly green sand. 36 of the 43 used green sand for the molding sand process. 7 of them used chemical binders. 5 used phenolic urethane no-bake. 1 used shell. 1 used phenolic ester. And in terms of the locations of the foundries, predominantly in the upper Midwest, as well as the South and the Southeast, and then a fairly good number of them in Pennsylvania. In terms of the analysis that was done on these samples, it really was significant, probably some of the most significant analytical work done on samples of foundry sand that I'm aware of. Initially, they conducted total analyses, in other words, a digestion of the sample, and those samples were then analyzed, or those digestions were analyzed for metals, polycyclic aromatic hydrocarbons, or PAHs, phenolics, and also dioxins and furans. And then in addition to the total analyses, they conducted side-by-side leaching tests using 3 leaching procedures that you see here, the TCLP, or toxicity characteristic leaching procedure, the SPLP, or synthetic precipitation leaching procedure, and the ASTM water leach method. Beyond the leaching studies and the compositional work, they also looked at plant uptake of metals from species that were grown in a 50-50 mix of spent foundry sand and soils. Then ultimately, they also looked at the poor earthworm in terms of impacts to earthworms that were in soils made of the 50-50 mix of spent foundry sand and soil. Now, that was the basis for the research. When all that work was gathered, the decision was made to involve US EPA in working with US Department of Agriculture in conducting a risk assessment based on this research. And basically, the question they set out to answer is, what is the risk of using recycled foundry sand in soil-related applications? Now, many of you probably don't know all that much about risk assessments. I'm certainly not an expert. But basically, in order to assess risk, you have to have 3 things. You've got to have a source of contaminants, if you will, that can be released from that source. Then once those contaminants are released, there has to be a pathway to take those contaminants away from the source and out into the environment. Then ultimately, you have to have a receptor, a human being, an animal, that comes in contact with those constituents that have been released from the original source. When you have all 3 of those, you have risk. If for any reason one of those 3 is missing, you do not have a risk. So for this risk assessment, our source, or the EPA's source, was recycled foundry sand. The pathways that they looked at the release of the contaminants, how those contaminants behave once they're released, because they're going to change. They're going to change chemical composition as well as concentration. And they looked at the different media of air, water, and soil in terms of how those constituents migrated away from the source. And then in terms of receptors, they looked at both humans as well as plants, animals. They also looked at how often these receptors were exposed to the contaminants. And this is the way US EPA defined protective. Now, as I understand it, we as human beings living on this planet have slightly less than a 40% chance of developing cancer of any kind over our lifetime. That's like a 1 in 2.5 chance of getting cancer. For this risk assessment, US EPA said they define protective as if the excess cancer risk, in other words, the cancer risk beyond what you have as a human being on this planet, but cancer risk nevertheless exposed, or that you would be exposed to if you were located near or had this mix of foundry sand and soil that you used on your property. If that excess cancer risk was less than 1 × 10⁻⁵ or 1 in 100,000, that was considered protective. In terms of non-cancer risk, they were looking to see whether or not there were any of those non-cancer risks that would be experienced over a human's lifetime. Here you see the exposure scenarios that US EPA reviewed. They looked at residents living near soil blending facilities. Obviously, if we start recycling sand the way we're intending to do, there's going to be some soil blending facilities where they're going to be taking spent foundry sands, mixing them with byproducts or other soil materials to create a manufactured topsoil. They also looked at home gardeners that would be using these manufactured topsoils in a garden environment on their property. Then they looked at the ecological receptors that would be living near a home that had a garden made out of these materials. In terms of the pathways, as I mentioned, we looked at groundwater, they looked at groundwater. They looked at both the ingestion of groundwater, drinking of groundwater, as well as dermal contact, washing your hands, bathing, etc., with groundwater that would have been impacted by these materials. In In terms of ambient air, they looked at inhalation that would have occurred and the risks associated with inhalation from dust. And then they also looked at soil, both in terms of ingestion of soil. I know soil is not the best thing to eat, but it nevertheless does happen, particularly with children, as well as dermal contact of the soil. And then ultimately, they also looked at ingestion of fruits and vegetables that would have been grown in a garden that would have had this manufactured soil. So let's take a look at the risk assessment process. As I said before, you start out with the available information, the research. That was the USDA work. That formed the basis. First question you ask is there sufficient data? US EPA looked at the data from USDA and said, yes, we believe we've got sufficient data. Once they answer that question, they go through a screening process, use some very conservative assumptions, very conservative risk numbers, and say, can we simplify this work going forward? Are there constituents that we can say, look, these are low enough, they don't pose a risk, let's move on and get to the other things that seem to be a little bit more of a concern. If you pass the screening, you're done. That constituent is done, that scenario is finished, it's determined to be protected. If for some reason you don't pass the screening level, then the next step is to go through more detailed modeling to try and answer the question whether or not the materials as used pose significant risk to the receptors. So as I mentioned, part of the screening step was set to eliminate as many things as they could to get down to what had to be modeled. Modeling is fairly expensive, so you try to rule out as much as you can before that. So US EPA decided to eliminate any constituent that was below the detection limit. Their rationale is if we can't detect it, we can't measure it, we don't believe it merits going any further. They also looked at, decided to rule out any constituents for which there were not benchmarks set. In other words, there isn't enough level of concern right now to have established a benchmark, so they ruled those out. And then if there were constituents below those very gross screening levels that I talked about before, and in this case, if the leachate coming out of those leaching tests was below a drinking water standard, or if the spent foundry sand and soil blend resulted in a risk screening level that was a factor of 10 below those risk screening levels, that constituent was ruled out. So basically, if screening criteria were exceeded, then you would go on and do modeling. Okay, here are the results. I'm going to go through each one kind of individually here. Basically, as a result of the risk screening process, both the PAHs, the phenolics, and the dioxins were all below screening levels for all three pathways. And I think this is extremely significant. We found in some states like Ohio, there were a lot of concerns about PAHs in the foundry sand. Certainly some of the things that we have in green sand, the sea coal, et cetera, by their very nature have some polycyclic aromatic hydrocarbons. But US EPA took a look at these phenolics and the dioxins, and they were all below the screening levels. So these were ruled out from any further assessment, which I think was very significant. In terms of the pathway or the scenario of exposure of inhalation of fugitive dust, here again, all constituents were at least one order of magnitude below the screening value, and that was deemed not to be an unacceptable risk. Dermal contact with groundwater and soil was also viewed to be well below the screening value, so it was ruled out as having less than significant risk. And then in terms of ingestion of groundwater and soil, as well as some ecological screening, when they went through the screening step here for these scenarios, et cetera, they found that there were 11 metals that did not pass the screening step and had to go on through some phase 2 modeling. And those 11 metals were antimony, arsenic, beryllium, cadmium, chromium, cobalt, copper, iron, lead, manganese, and nickel. It's interesting, if you had taken just soils data and put this through the same screening step, soils would have required to go through the same kind of modeling with the exception of the parameter of copper. So that's significant. And one of the other things that we asked US EPA to do and USDA, and they agreed to do this, and I think this is probably one of the most significant steps in this whole research effort. Basically, we asked them to compare these results to native soils. And what they found is, as you see here, that Foundry sand was similar to native soils. We all know that the materials that we're taking as raw materials are basically the same materials that are in native soils. And they found that at the 95th percentile, and I'll go over this in another slide, Foundry sand is typically lower than the median value, the middle value of U.S. soils. And then finally, here's another limitation I want to tell you about. The two copper-based Foundry samples that were analyzed, where they used a 10% mix of 10% Foundry sand and 90% soil material, resulted in some elevated concentrations of copper and zinc in earthworms. Now, these concentrations weren't high enough to kill the earthworms, but the concern was that species of animals that survive or use earthworms as food would be impacted by these elevated levels of copper and zinc in the earthworms. So as a result of this, the copper-based Foundry sands were eliminated from further consideration as a result of this conclusion. Okay, here are the conclusions from the risk assessment, real quickly. The metals that were found in the spent Foundry sand are present in concentrations similar to background in the U.S. and Canadian soils. For those of you that are in Wisconsin, this sounds a whole lot like cleaner than dirt, and it kind of really is. This basically is U.S. EPA coming to the same conclusion that folks with Wisconsin Cast Metals came to some years ago. Now the conclusions, again, only apply to silica-based sand from iron, steel, and aluminum foundries. Remember I talked about copper being ruled out? The other limitation here, this risk assessment, it only applies if you're using silica-based spent Foundry sands. There weren't enough samples of olivine sand. That, coupled with the fact that there were some elevated concentrations of, I believe, chromium in the olivine sands, ruled them out as not, the conclusions did not apply to foundries that use olivine sand. And this is the final conclusion of the risk assessment. Use of spent Foundry sand in manufactured soil, soil-less potting media, and road sub-base is protective of human health and ecological receptors. Basically, this is the U.S. EPA seal of approval, if you will, for use of our material in these ways. Now, as I mentioned to you, there's some very significant benefits to this risk assessment, and here's one I want to show you. A little hard to see, maybe a little not quite in focus here, but this is a summary of the risk assessment data, the research, if you will, from USDA, as well as the risk assessment modeling efforts that were undertaken. You see the elements here that were analyzed for compositional analysis, the heavy metals. The statistics associated with the soils are presented over in these three columns to the right. You see the maximum concentration for these constituents in the study. You see the median or middle concentration. Then you see the 95th percentile. They applied a statistical distribution to the data, computed the 95% upper confidence limit for these soils. And that was the number that was used for all future risk assessment. So in essence, when you get over here, you see that they have this column entitled SFS, manufactured soil. That ends up being the 50-50 blend of spent Foundry sand and soil. And you see if you take the 95th percentile value for arsenic, let's say it's 6.4, you divide that by 2, that results in the 3.2 concentration that was used for the screening process and the modeling going forward. And then they compared all these results that you see here to the site screening levels. These are site screening levels from US EPA, basically gross screening numbers, very conservative. And if the number over here on the left was less than 1/10 of the site screening level, which you see here, then there was no further work that was done, no more modeling whatsoever. And then if for some reason the value over here was not less than 1/10 of this value, as you see with arsenic, then they went on and did some modeling and compared those modeling results to the concentration in the mix of spent Foundry sand and soil. So this summarizes all of those things that I talked about before. The other key thing about this table I think that you should know about is this table these three columns on the right-hand side, they are the columns that summarize the data associated with U.S. and Canadian surface soils. And if you see this, you begin to if you compare the two, particularly at the 95th percent upper confidence limit, you'll see that by and large, the soil concentrations for many of the parameters, in fact, about 72% of the parameters in soil exceeded those in the Foundry sand, which we think is definitely a significant finding. Okay, how do we benefit from this thing? Well, if you're one of the 43 Foundries that was part of this original research, you have probably more analytical data on your Foundry sand than any other Foundry in the United States. And if you haven't already done so, I would strongly encourage you to contact USDA, and we can give you their contact information if you let us know. Contact them and find out which Foundry yours is in the research. They just list them as Foundry 1 through 43. You can find out, they'll tell you which one is yours. You now have all this data at your disposal, which we think is significant. If you're a Foundry that did not participate and you're kicking yourself because you didn't, don't despair. There's some benefits here to you. You can take a look at your concentrations in terms of total concentrations as well as pick out a leaching procedure and compare things there. If you are within the limits that you see in these tables, in essence, the conclusions that are drawn from this study apply directly to you. The big thing we have here is we've got third-party credibility. We have the U.S. Department of Agriculture, the Ohio State University, and U.S. EPA. And this work was all done predominantly under a Democratic administration, particularly the risk assessment. And if you take a look at what U.S. EPA had to say about this when they issued a press release, they said, by recycling Foundry sands in this way, we help address climate change, we improve air quality, reduce costs, and we're working towards a sustainable future. How green is that? Okay, continuing on, if you have an end user who wants to know, is your stuff safe? This research is a significant amount of data, provide them with probably more than that has been done for a lot of other industrial byproducts. Kind of take the approach, if it's okay for EPA, why should you be concerned? And clearly, as states are looking to either develop beneficial use rules or perhaps modify their beneficial use rules, we think the data in this research can help in that process. It also helps us look at the different leaching procedures, how our sands perform under the different leaching procedures. It's a great comparison between Foundry sands and native soils. And I think when you couple the research and the risk assessment together, I think you have a very compelling argument for beneficially reusing our materials in this way. So I hope with this presentation it's helped you to better understand what the risk assessment is and also what it's not, what the limitations are. And at a minimum, I hope I've summarized a 477-page document in 20 minutes that helps you get to focus on the most important aspects of things. With that, I'll turn it over.
All right, Dan. Hey, Dan, stay on the line for just a moment. One question did come in, and maybe you can give a quick answer. They say, we make magnesium. Why were there no mag foundries tested?
Probably at the time, we're going back, this took a total of 12 years. There just weren't that many that were identified as interested in participating. We can't get everyone. So you basically, we sent out a request to get as many participants as we could, and there just, in that sample set, were no magnesium foundries. It was not an oversight, it just worked out that way.
All right, well, thank you, Dan. Dan's overview of the risk assessment is very good. He does a good job in 20 minutes of boiling down that 477-page document. If you do or you don't know where it's at, you can go to epa.gov, type in the keyword spent foundry sand, and it'll bring you straight to the web page where you can find the risk assessment and other supporting documentation. Next to speak is Brian Esch from the Waupaca Foundry in Wisconsin. And Wisconsin's a great example of a progressive state on this matter, and he's going to kind of give us a little update on what's going on in Wisconsin. Go ahead, Brian.
Thanks, Greg. Yeah, I think Wisconsin definitely has been aggressive in this sense, and kind of thinking about what and how the risk assessment may be any benefit to the state of Wisconsin at all. I guess maybe to consider that, where to start would be just looking at the history of what's gone on in Wisconsin up to now, and just real quickly that pretty much in the late '80s, we had a time where there was some recognition that beneficial use projects had some benefit. There were some good legitimate uses out there, and basically what the state was doing was allowing projects to occur on a case-by-case basis. And a lot of these tended to be like big, significant DOT type projects where a lot of fill material was required, and it might have been an embankment or a base course and that sort of thing. So over a number of years, there was a lot of effort from Wisconsin Cast Mills Association to promote and work with the state on those sorts of projects. And over that time, there was just a lot of success on those projects on that case-by-case basis. And as mentioned earlier, as the success continued, and also there were some studies that were done in the state, really all rolling that all together, the Cleaner Than Dirt campaign really came to fruition at that time, and I'm proud to say that I have my Cleaner Than Dirt button here. I'm kind of wondering if it has a value on eBay, but I guess I'll find out someday. But nonetheless, all that led to what we know of now as NR 538, and that was in 1997. And basically what that did was put into a more standardized format of how to proceed with these kinds of projects. So that all started in 1997. So for any beneficial use history buffs out there, that was also about the time that FIRST came to fruition. Of course, the Foundry Industry Recycling starts today, which is the National Reuse Marketing Consortium. So what's special about NR 538? Well, in my opinion, a lot. One thing that I think a lot of parties might think is, as you go from state to state, and of course there's a lot of variety as you go through the states, some folks might think that maybe an industry or a foundry would prefer to have, I guess we'll call it a lax or a very general or open rule that allows you to do projects. And I think NR 538 took a different tact than that. And basically what it did is it created a recipe for success. So when you look at it, there is actually a fair amount of requirements, a fairly regimented amount of analysis and testing that has to be done. And as you can see from this slide here, not only total elemental analysis, but also the ASTM water leach. So using all those results, there were thresholds that were developed for each of those different kinds of tests. And using those is what basically slotted you into what they call a category. So there were categories 1 through 5. And the idea of these is that each of these categories had a preset uses that are already there. You didn't have to have self or a case-by-case anymore. So if you met the criteria, you could have essentially a self-implementing rule, and you can proceed with projects. So again, having that standardized format is a tremendous benefit, I think, to any industry or any party that's interested in doing beneficial use. And I think another nice thing about the rule is the fact that NR 538 also has some built-in flexibility in case you may have something that's a little out of the norm or not on the list. You do have an opportunity where you can submit your project with the necessary information, and they will still do like a case-by-case review of it and determine its acceptability. So here's an example of, when you look in the rule, the beneficial use methods and types of projects that a foundry would be allowed. So just to give everybody some perspective, for the most part, I think most of the Wisconsin foundries find their materials to be in either a category 1 or 2. So think of category 1 and 2 as being pretty much equivalent to native soils. And as you go up through category 4 and 5, you might see things like fly ash or something like that. So this obviously covers many industries. But as you go into a higher category, it's more restrictive, and you have less opportunities to use it on projects based on the nature of the material. But again, in the case of Wisconsin foundries, and particularly in the case of Wapaka Foundry, for many years, we very consistently have shown up as a Category 2, and if you look down the list, there's quite a lot of uses there, covering a broad spectrum of industries and opportunities where our plans can be used. So let's talk a little bit about how the risk assessment may have any impact on Wisconsin. So looking at the analysis results, which this is just a little clip of what Dan had showed in more detail earlier, but really in general, there is a very good conformity between the findings of the risk assessment and a lot of the work that Wisconsin has done in the past. So the Category 1 and 2 thresholds, there's just a lot of uniformity with the numbers that were found. And so essentially, there are no surprises in here. So I think that's very beneficial for the state of Wisconsin and any efforts they might have moving forward. And right here I'm showing the Category 2, which would be symbolic of something like the Wapaka Foundry materials. And these not only did these results support the risk assessment findings as they were described earlier, but again, they're also confirming compliance with existing Category 2 easily. So we normally find that the actual results found at most foundries for many of the parameters are much lower than the actual Category 2, which is a category which also already allows a lot of uses. And additionally, I think that the assessment has a lot of other comparisons and a lot of data in there, and there's going to be a lot of opportunity for folks in the state to utilize that information, because looking at Wisconsin's past, when NR 538 was initially developed, there was a very methodical and study-based approach to come up with the rule as we know it now. And I think that the risk assessment fits very nicely into that, because it has a similar completeness and all that to it. So, to be honest, there is an excellent timing that we're seeing here, because, of course, with the risk assessment being published and out there for use, and it's clear that EPA is beating the drum as far as the benefits associated with this study and these materials. At the I think there is some expectation that in the state of Wisconsin that this will be a topic of conversation in the world of beneficiary use. And maybe as things move forward, would it possibly be its own new self-implementing category? Very possibly, and I think that the information that's provided by USDA and EPA, it definitely supports that. So you see here down at the bottom where Wisconsin Cast Metals Association, which was a member of the Technical Advisory Committee back in the pre-1997 time when NR 538 was initially worked on, we have just fairly recently found, we mean Wisconsin Cast Metals Association, that NR 538 has, if you think of it from 97 to now, the state's decided that the time is right to basically reassess and modernize that rule. So from the time that this slide was put together, just in the last couple of weeks here, Wisconsin Cast Metals has actually been notified by Wisconsin Department of Natural Resources, requesting some folks to sit on a technical advisory committee to basically bring NR 538 into, to basically modernize it and update it. So, in that effort, you would have a number of individuals, probably 10 or more folks sitting in a group, and you would have byproduct generators, you would have end users such as DOT folks for the state, construction firms, and of course some environmental protection interests would all get together and basically crunch through the information and provide comments and basically work towards a result. And it sounds like that's all going to go on right now or it's next year. So again, the timing is excellent. So in conclusion, we have good timing here in Wisconsin for this study, and I think having this conversation about what it means. And in general, Wisconsin metal casters are excited to use risk assessment as a tool as we move forward and update NR 538.
All right, thanks, Brian. Again, Wisconsin's a great example. Brian talked about the possibilities of improving maybe the NR 538 with the risk assessment, but maybe other states can take the risk assessment in conjunction with Wisconsin's rule for beneficial use and use those to help promote change in your state. Next, Mike Lenahan is going to share with us how a coalition of industry partners and the EPA risk assessment were used to pass a major rule change through legislation in order to now have a really good beneficial use program. Go ahead, Mike.
Thank you, Greg, and thank you, Bryant. I'm going to talk to you a little bit about the Michigan story. The next slide is going to show you the new rule in Michigan. This was me in 2002 to 2014. I know I'm not quite that slim, but the proportions of the boulder and the hill are accurate. For those that have not been around beneficial use all that long, I can tell you that back in 2000, Michigan seemed to be a state where the willingness to work with foundries on meaningful change seemed to be very far away. The climate was just not collaborative enough to make any major headway beyond some recycling into manufactured products and use for daily cover. It's not an indictment on the MDEQ. They had a job to do as well, and they were simply very conservative in their approach. The previous beneficial rules were really ineffective, and previous efforts working with MDEQ did not bear any fruit. When we say unrealistic criteria, what we mean is that not even some native soils could meet the strict standards that were in place. Lots of paperwork was required. Let's just say it wasn't something that was easy to understand or implement. One key item relates to legal protection. Previously, you may have been able to use your material in a reuse application, but if the rules changed and became more conservative, you could very well have found yourself and your company on the hook for disposal of a previously approved material going into reuse. That was a major problem for the foundry industry in Michigan. Most of the above is in part my opinion, but when I compare Michigan to some of the neighboring states like Wisconsin, Indiana, Ohio, I really did see limited opportunity for reuse. Everybody recognizes that testing is important, but extensive testing of a material that's often made up of naturally occurring materials, like Dan had mentioned earlier, such as clay and sand, that does not vary, seem to me to be somewhat redundant. So if we were going to get anywhere, we knew we had to look at the creation of a comprehensive rule that would do all the things listed in this slide. I recall a conversation that I had with a regulator about 15 years ago where he accused me of wanting to recycle these materials so I could help companies save money. I confessed at the time that saving money was indeed part of the reason why people were interested in beneficial reuse, but it was not the only reason. And that conversation really told me a lot about how far we needed to come up with some kind of a collaborative improvement, really to educate the regulators more about our industry, more about what we wanted to do, and more about the type of people we were. So when we're looking at the anatomy of reform and groundwork that was done, this presentation really kind of reads like an after-the-fact roadmap. I mentioned the word autopsy, but that's really not a fair word because this is a success story rather than something that was bad. I can't emphasize how valuable the Foundry Association of Michigan was, not only as a standalone entity, but also recognized as a team player among Michigan manufacturing community. It's this activity involvement outside of our own Foundry family that really gave us visibility and a seat at the table when the winds of reform began to blow. We had, through our executive director, Bill Levensey, key relationships with the Chemistry Council, the pulp and paper industry, the utilities, and many of our other members. Like Dan Oman and myself had great relationships with other state groups, probably thanks to buying them a few beers, the OCMA folks and Wisconsin Cast Metals Association. Also, FAM was and still is a member of the Michigan Manufacturers Association, who ultimately played a huge role in our success. So as mentioned, we were plugged in not only with organizations, but through this with other companies. with some really, really smart people, by the way. Can't say enough about some of the engineers that work for these companies. The groundwork with lawmakers also paid off, not only a one-time thing. For those of you who have made trips to your state capitals or made trips to D.C., you really have to get to know the lawmakers over time, and it's a marathon, not a sprint. So having them tour our operations before any of the beneficial use rulemaking initiation ever came up had many of them very familiar with our businesses, our industry, and our people. They actually recognized us when we came into chambers. Some could be said, the same could be said with familiarizing yourself with the legislature and staff with our industry. It was a lesson taught to me well by the folks at AFS Washington like Jeff Hannapel and Stephanie Salmon. We did maintain a professional relationship with MDEQ. Even though we were butting our heads up against the wall often on trying to make some progress, we didn't always agree, but we certainly held a high measure of respect for them and them for us, which definitely worked to our benefit as we move forward. So after a multitude of meetings, more meetings, testimony, questions and answer sessions, reading draft after draft, comparing analytical to proposed rules, and again, a big thanks to Dan Oman because he and I sifted through a lot of this data over many an afternoon. House Bills 5400 and 5402 were introduced in March of 2014. You can see the materials impacted by the rule. Foundry sand is right there at the top. The impact of the testimony. I briefly mentioned testimony on the last slide, but this was huge for us. We had two very strong items we could point to as backup for creating progressive new rule. One of those was Wisconsin NR 538. It's a good time to thank Brian Esch here. I made several calls to Bryant during this process, and he always took them. I'm not sure if his caller ID was broken or what, but he was beyond helpful. The Holy Grail, that's the independent comprehensive study that we're talking about today. We were frankly the envy of our counterparts. People opposing us were frankly not about to take an unfair shot at us once they saw what we had in front of us with the risk assessment. The result, September 16, 2014, Governor Snyder signed House Bill 5400 into law. It was a very proud moment for all of us in the industry, and I think a very good moment for the state of Michigan. I was there and got my picture taken too, but it would have consumed the whole slide, so I'm just showing the legislative leaders and the governor. Why it worked? Well, most of you are aware there's been plenty of scrutiny late on Michigan as it relates to the Flint water crisis, but frankly, the issues relative to this are unfairly tarnishing a very collaborative administration. They wanted to work with us to create a better rule that would work for the businesses and also work for the people of Michigan. Snyder's administration was willing to work with both the industry sectors and the regulatory entities to initiate positive progress, and it worked. Our friends in other industry sectors played a big part as well. Automotive, General Motors was huge. The power generators, pulp and paper, companies that all provide very good jobs. The people understood what was at stake and acted responsibly to improve recycling opportunities for these materials. Finally, kudos again to FAM and Bill Levency. The regulatory relationships were enormous. Being an MMA member, long-standing, was huge. Those folks know us as well. And then having the other industry friends, partially in crediting Michigan Manufacturers Association for giving us an opportunity to get together on like issues. And again, the Holy Grail, an independent risk assessment that you have today is Foundry people. I love the language, and that's what I'll close with, that finally we have an ability to use iron, steel, and aluminum foundry sands that pose no risk towards human health or the environment beyond that of native soils. With that, I'll hand it back to Greg.
Hey, thanks, Mike. That's a great story. And right now, Minnesota is working on a similar story. But, you know, we're not quite to the point where we've established a new BU rule. But I'll talk about Minnesota for a second. All right. Metal Casters of Minnesota is a nonprofit trade organization, and has been attempting to work with Minnesota Pollution Control Agency on beneficial use reform for over 20 years. Sorry, I'm having issues with my PowerPoint and other programs up. Anyway, now, finally, the group has begun gaining some real good traction over the past several months with the release of the EPA risk assessment. Pre-1990, MCM members watched foundries across the U.S. successfully reuse foundry sand in various applications. In the 90s, MCM began reaching out to various agencies and other industries to form a coalition to promote beneficial use in Minnesota.
Ultimately, Greg?
The lack of knowledge. Yeah.
Greg, Shannon, can you share your screen, please?
What's that? Oh, I'm very sorry. All right.
Thank you.
Sorry about that, everyone. But as far as Minnesota goes, ultimately, back in the 90s, the lack of knowledge on the environmental impacts of foundry sand and environmental liability put the conversation on hold. The conversation started back up in early 2000s timeframe, and actually a bill was proposed to update the Minnesota solid waste rules to include a new beneficial use program, and ultimately it was passed into law. MCM submitted public comment during this process and testified to request that the solid waste rule revisions be modeled after NR 538 because it was tried and true and it worked. MPCA ultimately decided that the New Jersey regulatory language was going to be used as a model for the Minnesota solid waste utilization rules. This included case-by-case determinations in addition to a list of pre-approved applications, or as Minnesota's rule calls it, standing uses. As a concession by the MPCA, a standing use was provided for foundry sand use in the manufacture of Portland cement. The problem is there are no Portland cement manufacturers in Minnesota. Also, case-by-case determinations under this rule have been largely unsuccessful due to the fact that it does not give adequate guidance. Unlike NR 538 and HB 5400, Minnesota's current rule does not provide testing requirements, elemental and leachate limits, methods, etc. And the lack of guidance means foundries really don't know, even prior to submitting an application with initial sample data, whether the project will even pass the first sniff test. Permit engineers have no guidance as to what is acceptable and what is not. They may be very apprehensive to take on that environmental liability, and therefore many projects don't get approval. This lack of guidance leads to more testing, retesting, back and forth correspondence with the PCA, wasted time, money, and effort. Only 4 case-by-case foundry sand beneficial use projects have been approved in Minnesota from 2006 to 2016, and 2 of them never utilized. This risk assessment changes things. Since the release of the risk assessment in October 2014, the MPCA has been very receptive to reopening solid waste utilization rules and talks of beneficial use. Metal Casters of Minnesota initiated contact with the MPCA in early 2015 and have had 4 formal meetings with them to date, formulating a plan of action. MPCA even took it upon themselves to contact WDNR, inquiring about any issues or public outcry with beneficial use projects under 538. There were none reported. MPCA hired a full-time permit engineer whose interim responsibilities are solely focused on beneficial use program. And MPCA is also committed this last winter to visit some of our foundries just to gain more knowledge on the matter. The MCM's Foundry Sand Technical Group and MPCA's Solid Waste Division are working closely together on a short-term plan and possibly even a long-term plan. The short-term plan is to draft a guidance document specifically for the foundry industry, structured similar to Michigan's HB 5400. This guidance document will be able to be used by both Foundries and MPCA to help make case-by-case determinations more streamlined. The long-term plan would be to introduce a bill at a legislative session, much like they did over in Michigan. And this type of rule change would be required in order to standardize and streamline beneficial use projects of all kinds across several different industries. So nothing has been completed yet, but we're getting somewhere in Minnesota at the moment, and it's due to the persistence of an active trade association and the influence of the third-party conducted risk assessment of spent foundry sand. So we even got an email last night for us to review some of what MPCA has put together so far for the guidance document. So making good progress. What about your state? We talked about it a little bit before. How can you get involved and use the risk assessment to advance beneficial use in your state? I think the risk assessment makes a strong case. Other states are doing it. And I think there's a lot of opportunity for all of us to glean from this document. Some of the keys to success that we kind of pulled out of the 3 case studies here are you need to understand what your rule is currently. You need to know the risk assessment study and use it to identify opportunities to improve your rule. You need to join forces with local trade associations, foundries, and other industries. You need persistent communication with lawmakers and regulators. And again, other states are having success. Use the template from those that have been successful. That's kind of where we're at with webinar number 1. Next week, we'll do a second webinar. Today's webinar was about the risk assessment and how to advance beneficial use in your state. Webinar number 2 will cover the things you will need to do in order to advance beneficial use in your foundry through implementing best management practices to provide a consistent and clean product to the end user, educating end users and potential end users of what a great product foundry sand is, and identifying the resources and tools that are available to you for beneficial use. So we'll get on that next week. So again, here are email addresses for all of our presenters today, and feel free to contact any one of us. There's a plethora of information on the AFS First webpage. You can go to it, the AFS webpage, and go to Environmental Health and Safety tab and get to it that way. And then also the EPA Risk Assessment webpage if you want a copy of that study. So we're pushing close on time here, but we can grab a couple questions that came in. And some of them were kind of asked before we told you where you could find the EPA's risk assessment document. And so I'll skip over a couple of them here. But one question was, any comments on physical testing, angularity, sieve size, etc.? It seems our sand is too rounded for the construction uses. I would say to that, and anybody else can jump in as far as the panelists go, but the EPA has no jurisdiction over those physical characteristics. Those would all be standards by like the construction industry or the DOT that specify that. So any other insight on that matter?
This is Mike Lenahan. I'd be glad to follow up with that question offline if the person that submitted it wants to reach out to me via email. Again, your comments are right, Greg. Not a regulatory issue, but maybe something on beneficial use background would help talk about some places where those materials could get reused.
All right. Another question. Do you know of anyone in or near Texas currently recycling or reusing foundry sand? I don't, but again, you go to that AFS First webpage, and you go to there's a section on state rules, and it pulls up a map. You can select the state of Texas. It'll have a summary of what the rules are in Texas. It'll it'll also, I think, also list some case studies of people who have done it. So AFS First webpage is an excellent resource that can answer a lot of your questions.
Greg, this is Dan Oman. I believe there's a Foundry that was, I don't know the name of the Foundry, but I believe I've heard about a Foundry in Texas that was using their Foundry sand in conjunction with recycled concrete aggregate as a road-based material. But that's the only one that I'm aware of. Maybe somebody else, maybe Mike knows some others.
Yeah, not off the top of my head, Dan.
All right, Shannon, maybe you can answer how we're going to distribute the presentation slide. We had a question, will these presentations be emailed to us, or how can people get a copy and a recording and everything?
Yes, we'll be sending a recording of the webinar to attendees and those who've registered, and they should be getting that at some point tomorrow morning.
Wonderful. And then I know we're going to be posting it on the AFS webpage, and I think the AFS First webpage as well. Is that correct?
Yes, it will be up there on the website probably sometime next week.
Wonderful. And then Dan, I believe it's listed out in the actual 477-page study, but in the risk assessment, were the results of phenolic urethane sands separated from green sand? The results of those testing?
No. The simple answer is no. Everything was all shown together. What you would have to do is you would have to go back in and look at the description of the foundries and find those foundries that phenolic urethane no-bake, find out what numbers they were, and then go to the tables and look at all the results associated with those corresponding numbered samples. But I don't believe it was just broken out, as separate 5 lines of data. It's intermixed in the table, but I believe you can go back into the risk assessment and make that determination yourself. It just takes some effort on your part.
Right. What are the chances of expanding beneficial use material definition to baghouse dust? I can speak for what we've been going through in Minnesota, and I think that's defined by each state. So like in the Minnesota guidance document for foundries, several materials are listed, and parameters or requirements are different for the various materials depending on what application it's going to be used in and so forth. So this study was just done on foundry sand, but there are applications for other beneficial use of other materials that some states regulate.
And Greg, this is Brian. Just to add what you had mentioned, that some states also recognize, for example, baghouse dust, depending on where it's being collected off of, it could be recognized as sand dust fines, and that is sometimes determined to be equivalent with foundry sand. So you have to look at your state rules.
Right.
I would weigh in. This is Mike Lenahan. I would say the exact same thing. And it's state by state dependent. Analytical can differ depending upon the origin of the material.
All right. Well, we went a few minutes over here. If we missed any questions to answer live, we'll have answers to those in some follow-up emails. But I would like to thank all of our presenters, and panelists, and all the attendees.